Hi there. In this video we are going to be talking about energy unit conversion. So it's unit conversions, but we're dealing with energy. The thing is, the concept of energy took a lot of history and a lot of human effort to figure out the underlying unifying concept. There were a lot of things that seemed separate and unrelated for a while that eventually scientists came to realize were all the same thing, this thing that we call energy. But a result of this long road to understanding energy means that over time, humanity developed a lot of different units to measure the same thing. And so we want to become familiar with all of these different units and how to convert between them. So the unit conversions are here. It may be worth actually pausing the video to write them down, but I'll talk you through them right now. So first of all, a calorie with a lowercase c and a calorie with a capital C are not the same thing. So it's already confusing. One lowercase c calorie is 4.184 joules. Both are units of energy. So when you're talking about calories in your food, you are talking about how much energy content is in that food. However, the food measurement is a capital C calorie, which is the same thing as a kilo lowercase c calorie. And so 1,000 lowercase c calories make up a capital C calorie or a food calorie. It is case sensitive there. I wish I could tell you differently because it is annoying, but it is the way that it is. We also have this British thermal unit, which is related to burning barrels of oil, which was another way to quantify energy, the British thermal unit, or the BTU, and that is 1,055 joules. So BTU here stands for British thermal unit. There we go. Whew, handwriting there is terrible. That's a bit better. Okay. Some reminders that a watt is defined as a joule per second, so that's not new. But we can multiply both sides of this equation by seconds to say that a joule is a watt times a second. This one is incredibly useful when dealing with electrical energy. So it's important to remember that a joule is a watt times a second because a watt is a joule per second. It's also helpful to remember that a joule is defined as a newton times a meter. And there is also this weird unit of energy. So an erg is a unit of energy. And it's what you get when you take a dyne of force instead of a newton of force and multiply by a centimeter of distance instead of a meter of distance. A dyne is a force unit, just like newton or pounds. And a dyne is defined as, instead of a kilogram, a gram, times, instead of a meter, a centimeter per second squared, which there are 10 to the minus 3 grams in a kilogram, 10 to the minus 2 centimeters in a meter, so overall that's 10 to the minus 5 newtons for a dyne of force. This would actually be the maybe easier unit to use in the lab because we measure everything on our scales in grams and centimeters, and in fact that's where this unit comes from. But the SI unit for force is newtons, but dyne does exist as well. And then a reminder that in the US, a pound is a force unit that's equivalent to 4.45 newtons of force. So this works the same way as any other unit conversion, but there's all sorts of confusing brand new units to keep track of. So I want to look at this example together. We have an LED light bulb. It uses 342, what is that number? 34,200, woof. 34200 joules of energy in 1 hour. And we're going to go through 5 questions related to this light bulb. The first question being, what is the power output in watts? Well, the power is the change in energy per time, which we do know is 3,400, I can't say that number, 34,200 joules per 1 hour. So that looks pretty good, except for the fact that we want it in watts. And a watt is a joule per second, not a joule per hour. So we need to convert this hour to seconds. And to do that, we'll multiply through by the denominator. I need to cancel it, so I'll put it in the numerator. And I don't know hours to seconds, but I do know hours to minutes. And I want to cancel that minute, so I'll put 1 in the denominator here and replace it with the seconds. I know that in 1 hour there are 60 minutes, and in 1 minute there are 60 seconds, and I know this hour in the denominator will cancel with that hour in the numerator, and this minute in the denominator will cancel with that minute in the numerator, so I'll be left with joules per second, which is the same thing as a watt in the end. So it's this 34,200 divided by 60 divided by 60. And if I go and do that in my calculator real quick, that's 34,200 times 1 over 60 times 1 over 60, and you get 9.5 for that. That is 9.5 joules per second, or the power is 9.5 watts. A reminder on the calculator here, the other way you could do that is you could type in 34,200 divide by 60 divide, oh hello, I didn't want that. Give me a second. I don't even know what this is. How does this go away? Give me a second here. What's happening? Alright, good. So you can do 3,400 divided by 60 and just do divided by 60 twice, and you should get the same result of 9.5. Excellent. So it's 9.5 watt LED light bulb. Next, this is an unusual unit to measure power in, but we can do it. What is the power in calories per minute? This works because calorie is an energy unit, and it isn't. And so what I'm going to do is just write that as 9.5 joules per second, which is the same thing as a watt. I want to convert the joules into calories, lowercase c, and the seconds into minutes. So I'll start with the energy unit. I have joules already, so I want to divide by joules to cancel. And I want to convert it to lowercase c calories. And I know from this chart up here that 1 lowercase c calorie is 4.184 joules. So 1 lowercase c calorie is 4.184 joules. And so when I do division, those joules will cancel and I'll be left with calories. So I right now have calories per second. I want calories per minute. And I have seconds in the denominator, so I'll need seconds in the numerator there. And instead of calories I want. What do I want? What am I doing? Minutes. That's what I'm doing. And I know that there are 60 seconds in 1 minute, and I know that this seconds here will divide with that seconds in the numerator, one numerator, one denominator, and I'll be left in the end with calories per minute, which is my end goal. So I'm going to type this one in as 9.5. I could do it as times 1 over 4.184, or just divided by 4.184, and then times 60. And when I enter that into my calculator, I get 136.233, or I had 3 sig figs before, so I really should be saying 9.50 on these. That is 4 sig figs. That's infinitely precise, because it's exactly 60 seconds in a minute. And so I have 3 sig figs here. 136 is the number I want, and the units are calories per minute. Cool. Next question. What is power output? So it's the same power, just in different units. And the units we want now are erg per week. So let's go ahead and do that. I'm going to start with the same 9.50 joules per second. And this is going to take a minute to get there. What do I know about an erg? I know an erg is a dyne centimeter, and it's related to energy because the joule is a Newton meter. So the first thing I need to do is say that this is the same thing as well, actually, no, that's not how I'm going to do this. JK. All right, start over. 9.50 joules per second. I want to get to dyne centimeters, which is the force times the distance. So I'm going to start by saying, all right, I know a joule is a Newton times a meter. That's a 1-to-1 conversion because that's the definition of a joule. But that will be helpful for us because I know how an erg is related to force and distance. So joule will cancel with joule. That all looks fine and dandy. Next, I'm looking for ergs and centimeters. Sorry, I'm looking for dyne and centimeters. And I know that a dyne is a force unit, so it'll be related to the Newton that I have there. And this little table tells me that 1 dyne is 10 to the minus 5 newtons. So, 10 to the minus 5 newtons in 1 dyne. And the Newton will cancel with the Newton. So I'm close because an erg is a dyne centimeter. I've got dyne meters, right, to convert the meters to centimeters. So I've got meters in the numerator. I'll need to put a meters in the denominator there. And I want to convert it to centimeters. And that looks good. Centi is a metric prefix. That means 10 to the minus 2. So I need to put a 10 to the minus 2 in the denominator so that the centi and the 10 to the minus 2 in the denominator balance to 1. So I have now canceled my meters, and I have dyne, that weird new force unit, and centimeters. And I know, by definition, that 1 dyne centimeter is 1 erg. That is the definition given up here in this table. So, I have 1 erg is 1 dyne centimeter. Dyne cancels with dyne. Centimeters cancel with centimeters. Even though dyne is a new unit and erg is a new unit, the rules for unit conversion still are the same. And I have erg per second now. So I'm done converting the energy from joules to ergs. I just need to convert the per seconds into per weeks now. So I'm going to start dealing with this time unit. So I have seconds in the denominator that I need to cancel, so I'm going to put a seconds in the numerator. I want to end up at weeks. I have seconds. I know that there are 60 seconds in 1 minute. I'm going to kind of fast through this one. I also know that there are 60 minutes in 1 hour. I also know that there are 24 hours in 1 day. And I know that there are 7 days in 1 week. Make sure everything canceled correctly. Seconds in the denominator, cancel with seconds in the numerator there. Minute, minute, hour, hour, day, day, and I'm left with weeks in the denominator. So it's a long chain, but it is just a chain of sifus, of forms of. I go to this whole chain into my calculator. I have 9.50 times 1 over 1. You really don't need to type this into the calculator, of course, but I really want to emphasize what we're doing here. Times this one you do need to type into your calculator. 1 over 10 to the negative 5th times 1 over 10 to the minus 2 times, keep going, 1 over 1. Again, this one's not going to change anything in the calculator. Times, that's 60 over 1. Times another 60 over 1. Times 24 over 1. I'm just going to type 24 times 7. Enter. That is 6.7456 times 10 to the 13th power. So writing down that answer then, we are writing down 5.75 times 10 to the 13 erg per week. It's a weird power unit, but it is still energy, ergs, divided by time, weeks. So it's not a SI unit, but it is a unit we could use. We expect a big number because it's an energy used over a full week, not just over a second or a minute or an hour. Cool. Let's keep going from there. Got 2 more I want to look at with you all. The first is here. In electric companies like Ameren, that's who supplies the electricity here in St. Louis, measure energy in a unit called kilowatt hours. Notice the dash. It is not kilowatt per hour. It's not that. It's a kilowatt times an hour. And we don't know how much energy the light bulb uses. in 1 hour in energy units of kilowatt hours. So, we know that the original problem says we use 34,200 joules in 1 hour. So we're going to start there. 34,200 joules is the energy used in 1 hour. And we're going to convert it to a different energy unit called kilowatt hours. The way we're going to do that is by definition of joule. We know that 1 joule is equal to 1 watt second. That's the important one to remember. Take your joules per second times your seconds, you'll end up back at joules. A joule is a watt second. So, joules cancel with joules. We're now ready to convert watts to kilowatts and seconds to hours. I have watts in the numerator, so I need a watt in the denominator, and I want kilowatts. Kilowatt stands for 10 to the third power, so I need a 10 to the third power in the denominator to balance out the kilo that's there. So check, I've got the kilowatt part of kilowatt hours. Now I need the hour part, right? Watt will cancel watt. Convert seconds to hours. Seconds in the numerator, seconds in the denominator. Seconds to minutes, and 1 minute is 60 seconds. Multiply by, in 1 hour, there are 60 minutes. Minutes cancel with minutes. Seconds over here cancel with seconds over there. The uncanceled units are kilowatts times hours, which is exactly what we are looking for. So if I plug all this into my calculator, I have 34,200 times 1 over 1 divided by 10 to the third divided by 60 divided by 60. And if I press enter, I end up with approximate enter 0.0095 kilowatt hours. 0.00950 kilowatts times hours. So that's an energy unit. Kilowatt times hour tells us how much energy a 1 kilowatt device would use when powered on for 1 hour. So it's not a per there. Not a per at all. All right. Joules a watt second. I'm just double checking my work here real quick. That looks good. That's good. Okay. Last but not least, costs 12 cents per kilowatt hour. What does it cost to run the light bulb during that hour? So this is the energy it uses in an hour. 0.00950 kilowatt hours. And I now know that it's 12 cents per kilowatt hour. It's a unit conversion thing too, from energy to cost there. Kilowatt hour is in the numerator. So I'm going to put it in the denominator. I'm going to put cents in the numerator, and the conversion rate there is 1 kilowatt hour costs 12 cents. Kilowatt hour cancel with kilowatt hour, and I am left with, when I take this number times 12 in my calculator, I get 0.114 cents. So this light bulb doesn't even cost a penny. It's a little bit over 1/10 of a penny to run for an hour. That's pretty inexpensive. So, those are our energy unit conversions. Again, I'll pull up this table here. It is worth writing this table down. It has all of the weird units we might investigate, this weird dyne force unit, this weird erg energy unit, lowercase and capital C calories, and British thermal units. It's weird units, but otherwise it's unit conversions, business as usual.